Hello students. Now in this video we'll go for the fifth form of the equation of straight line. Already we have seen four forms, that is slope point form, the second is slope intercept form, third is 2 points form, and fourth is a double intercept form. And now we'll go for normal form. Already we are familiar with the word normal. Normal means a perpendicular drawn on that line from a fixed point. So we'll see what is the meaning of normal here and how we can write that normal form equation of line. So we consider a line L here, so that line, and on this line we have drawn a perpendicular line segment from origin, that is ON. So it is called as a normal, the perpendicular drawn from origin on the line. So this is the normal ON. And now see what is the information given here. This normal line segment ON has a length is equal to small p, and it makes an angle alpha with positive direction of x-axis. Now we may consider Pn as the polar coordinates. Small p it is, and alpha. These are the polar coordinates of n. So we can find the Cartesian coordinates. As usual, we consider the general point of this line, it is capital P, xy. Okay. Let the normal ON is such that this ON is equal to small p, its length, and angle NOA is equal to alpha. Then polar coordinates. Already we are familiar with the polar coordinates. This r theta of this point N will be this P alpha. And using polar coordinates, we can write its Cartesian coordinates. That is xy coordinate of N. Now we know that if r and theta are the polar coordinates, already I will write that here. If r and theta are the polar coordinates, then its Cartesian coordinates xy for the same point can be obtained using the relation x is equal to r into cos theta and y is equal to r into sin theta. So here r is small p and theta is alpha. So the coordinates of n will be p cos alpha, p it is small p, sin alpha. So this is the point on this. Then slope of this ON will be, I will denote it by small m dash. And we have the coordinates of O, it is 0, 0, and coordinates of N as just we have obtained as P cos alpha, P sin alpha. So y1 minus y2 divided by x1 minus x2, difference between y coordinate. Now P sin alpha, that is the y coordinate of N, minus y coordinate of origin is 0, divided by x coordinate of N, this is P cos alpha minus 0. And so we are getting this. P sin alpha is divided by P cos alpha, cancelling P from numerator and denominator, we are getting slope of ON as it is tan of alpha. As ON is perpendicular to line L. Already this is by construction. So slope of L will be, L lines are slope L, it will be denoted by M. Now these two line segments are perpendicular. This line is perpendicular to line segment, or line segment is perpendicular to line. So we have the property for perpendicular lines. What is that? If two lines are perpendicular to each other, then their slopes are negative reciprocal of each other. Their slopes are negative reciprocal of each other. So M will be minus 1 upon M dash. That is minus 1 upon tan alpha, and now it will be minus cot alpha. Okay. And now see here, we got two things. First, that the point of line L. N is point on the line L whose coordinates are p cos alpha, p sin alpha. And we got the slope of line L. And we have to find then equation of line L will be obtained. Because already we have slope there. So we'll use slope and we have point there. So slope point form obtained by slope point form here. What is that slope point form? Y minus y1 is equal to m into bracket x minus x1. Here x1 y1 is p cos alpha, p sin alpha. So we'll put those values. Y minus y1 is, it is p sin alpha is equal to m. Now this m minus cot alpha may be written as minus cos alpha divided by sin alpha into x minus x1 is p cos alpha. Just I have written cot alpha as cos alpha divided by sin alpha here. Now transfer this denominator on the other side, sin alpha on left hand side, and multiply by this minus cos alpha inside the bracket. So it is y into sin alpha minus p into sin alpha into sin alpha. This will be sin square alpha is equal to minus x into cos alpha, and now it will become minus minus plus p into cos alpha into cos alpha. This is cos square alpha. And now these are the constant terms. These two are the terms of variables. Collect the terms of variables on left hand side. That is x into cos alpha. It was minus x cos alpha on this side. Transfer on another side. So it is x cos alpha plus y sin alpha is equal to p. This sin square alpha, p sin square alpha, it is negative on that side. So it will become positive p sin square alpha plus p cos square alpha. So here we may take p common outside. This is sin square alpha plus cos square alpha. No change on left hand side. This is x into cos alpha plus y into sin alpha. And that is, we are getting the final result. It is x into cos alpha plus y into sin alpha is equal to, the value of sin square alpha plus cos square alpha is 1 by identity, and so we are getting this p. And this is the equation of straight line. See what are the terms occurring in this equation. X and y, they are the standard variables, coordinates of general points. Alpha and p. What is alpha and p? Alpha is the angle made by normal with positive direction of x-axis in the diagram, and p is the length of the normal. So if these two things are known, we can easily write the equation of line. So this is called as normal form equation of line.